Hello again. So hopefully you have this worksheet in front of you that I sent to you, the change of base formula. And I just want to talk about a handful of problems on this, just so that, again, you have some knowledge before you get to class on Tuesday. But you are also going to need your calculator with you for this. So if you don't have that, would you please go get it right now? Okay. So we talked about how on your calculator, again, unless you've got some really swanky one, on your calculator, there are only two buttons that you can use for log. Log, right there, and then ln, right there. Again, log, this button stands for log base 10, not log base 2 or log base 3 or anything like that, just strictly log base 10. And this is natural log. It stands for log base E. And again, we said the character E represents the number that's like 2.72. And so if you want to use your calculator to find logs, these are the only two buttons that you can use, which is unfortunate when we get to problems like number 1 on this sheet, because this asks us to find log base 3 of 3.3. So if you thought, hey, let me do my homework and I'm just going to use my calculator to do that, at this moment you don't know how to do that, because this is not going to help you and this is not going to help you. So before we do that, I just want to show what you would have done before this conversation, which was you would say, okay, well, I don't know what power I would raise 3 to get 3.3, so I'm just going to fill in an x here. 3 to what power equals 3.3? And again, when we did these problems before, we would rewrite it in exponential form, so we would say 3 to what power equals 3.3. Now, in previous problems that we've done, this might not have been a 3.3, this might have been something like a 27. All right. And so we were like, oh, cool. I know that 27 is 3 to the third. And so if I can rewrite this, 3 to the x equals 3 to the third, then I'm just going to set the exponents equal to each other and conclude that x must be 3. But when we have something like, not like that, but the problem that we do right here, 3 to the x equals 3.3, there is no exponent that we know of that we can raise 3 to get 3.3. I can tell you it's going to be bigger than 1, because 3 to the first is 3. That's too small. We want 3.3. And 2 is going to be too big, because 3 to the second is 9. So x is going to be somewhere between 1 and 2, probably much closer to 1, definitely much closer to 1, but we still don't know what value it is. And you're certainly welcome in any time like this to just play around with your calculator and say, let's say 3 to the 1.1. Well, that's close but too big, so let me try 3 to the 0.9. Well, that's too small. Sorry, whoa, not to the 0.9. No, yeah, I didn't want that. I wanted something bigger than 1, but less than 1.1. So let's try that again. 3 to the 1.09 is what I meant to do. Okay, so that's getting closer, still too big. So then let me try 3 to the 0.8. Nope, 1.8, 1.08. All right, that's too small. So you could keep going back and forth and trying it, but there is a nice, easy way for us to do that, and this is called the change of base formula. So the change of base formula says that if I have log of log base b of some number a, and b is not a 10, because then we could just use our calculator, and b is probably not e, 2.7 something, so, because we could use our calculator. So imagine b to be something like 3 or 5 or 20 or something like that. That I can rewrite this as log base c, some other number, usually 10 or e, of a over log base c of b. So what this change of base formula does is it takes us from a base for which we cannot use our calculator into a base in which we can use our calculator. Right now, if you're feeling like, oh, another formula for me to memorize, visually what's happening here is if you can't remember whether B or A goes on top, remember, as we're reading along, log and A are on the same line and B is a subscript. So if I'm thinking about where I should put log of A in my formula, remember, it sits up higher than B. And so my formula, log base C, again, C is probably 10 or E, that is going to go up top, and the B, which sits lower, is going to go in the denominator. All right, so let's see what that looks like for this. So I'm going to take my log base 3 of 3.3, and I'm going to rewrite it as log base 10. Again, you don't have to write that, I will for just a second. Again, I'm going to take the one that's higher up here, the 3.3, over log base 10 of the lower one, the 3. All right, it's not lower meaning smaller, it means lower, it's sitting in a lower position, it's a subscript. All right, and when I do that on my calculator, right, you're going to press the log, because again, that's log base 10, and you're going to enter 3.3. Please do not forget to close your parentheses here, because otherwise it's going to divide by whatever log base 10 of 3 is. You don't want it to do that. You want it to, and then take the log of it. You want it to close it off and then hit divide, and then we would get divided by log of 3. And when we do that, we get 1.0867. It says to the nearest thousandth, so this is tenths, hundredths, thousandths, so I would say that this is approximately equal to 1.087. And again, when I was just playing around with my calculator, I found that it should be around that value, right? Now, two things that I just want you to see, if I didn't close that parentheses, what would happen here. So I clear that and I do log of 3.3 divided by log of 3, and I close the parentheses. Now, it's going to give me the wrong answer. All right, so make sure that you close the parentheses after you enter this 3.3 in, and then divide, because again, order of operations says it's going to do whatever's in the parentheses. So if you start the parentheses here but don't close it, it's going to keep doing whatever you say after that before you end the parentheses. All right. I know I said second thing, but I can't remember what it was. But anyway, all right, let's move on to number 2. All right, so log base 2 of 30. Before we do this, I just want to come up with an estimate, because again, if you make a mistake in the order in which you put these, if you've done an estimate ahead of time, that will help you figure out that, oh gosh, I did that wrong. So about how many times would I have to multiply 2 by to get to 30? In other words, 2 to what power is 30? So if I do 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5 times to get to 32. That's too big, but 4 only got me to 16. That was too small. So I know that my answer should be somewhere between 4 and 5, and it's probably going to be closer to 5 because we were pretty close to 32, or 30 is pretty close to 32. So I'm going to guess that the answer is going to be less than 5, but close to 5. All right, so then let's do this. Again, we're going to take log of the number that sits up higher. It just happens to be the bigger number too, but it's not, when I say higher, I don't mean bigger. I mean just elevation-wise, it sits up higher. I'm not going to write the 10 this time, but it is log base 10 of 30 over log base 10 of 2. And then I'm going to put that in my calculator, and I should get something in the high 4s. So I'm going to do log of 30, close my parentheses, divided by log of 2, close my parentheses, and I get 4.907 as my answer. All right, now I just want you to see, again, if you hadn't predicted that it would be close to 5, but less than 5. And you accidentally did log of 2 divided by log of 30. Whoops. You get something that's way, way off. But again, if you didn't have an idea in your head of what you were looking for first, you might just write that down without even giving it a second thought, right? So just take a minute before you do it to just make a prediction there and say, hey, I think that it's going to be this. And that way, if you're close, you'll feel confident. And if you're far off, you'll go back and check to see what you did. All right, let's look at number 8. This says log base 4 of 3.5. And the reason I picked this one is because this number that we're taking the log of is lower than the base. So I just want you to see what happens there, what kind of answer we'll get. So hopefully, if you think about this, it's saying 4 to what power equals 3.5. If we try 1, right away we know we're too big. 4 to the first power is 4. This is 3.5. So we know it's not even going to be as high as 1. It's going to be less than 1. Right? So this is less than 1. But again, 4 to the first power equals 4 is not that far off from 3.5. So even though it's less than 1, it shouldn't be too far from 1. So fairly close to 1. Okay, so let's write that out. Log of the number that sits up higher here, 3.5 over log of 4. Right? You can go ahead and do that on your calculator as I'm doing that. Log of 3.5 divided by log of 4. And I get 0.904. Right? So again, that's about, you know, we are not surprised by that based on our prediction. Oops, 0.904. Okay, one more thing I want to point out to you, and then I'm going to let you go. I've been using log base 10 for these, but what happens if I do natural log of 3.5 over natural log of 4? If this change of base formula is worth anything, it shouldn't matter what base we do it, so we should get the same answer. So let's just confirm. That way, if you develop a really strong fondness for natural log and you want to make sure that you can use it as often as possible, that you can still use it here. So natural log of 3.5 divided by natural log of 4. Same thing. All right, so it doesn't matter what you use, you will still get the same answer, 0.904. Okay, that's all I got for you.